Hello, happy people. This is Mr. Wilcox with another lesson for pre-calculus. We have evaluated functions with numbers. We've evaluated functions with expressions. We've done composition of functions by putting a function within a function. And today we are going to add, subtract, multiply, and divide functions. So we're going to do operations with functions. So, for adding and subtracting functions, here is what we're going to do. So I'll explain it and then we're going to do this example. So for adding functions, we're just going to combine any like terms to simplify. And once it's as simple as we can go, we are done. You're usually going to see it as a function plus a function. That's how I'm going to show it. Another way you can see it, maybe in your book, or when you go to calc class in the future, you could see this f plus g of x. That means the same thing as f of x plus g of x. So subtracting, to subtract functions, remember we change the subtraction to addition in the middle, and we change all the signs of the second function. And again, you can either see it as f of x minus g of x, or they might put it in parentheses where it's f minus g and then of x. It means the same thing. They'll put it in the order they want subtracted. So f of x minus g of x, f minus g. If you see it switched, then it's switched, all right? So let's actually do those two examples. So we still have f of x equals 2x minus 3, and g of x equals negative x plus 7. And we're going to try f of x plus g of x. So I'm just going to take 2x minus 3 and add it to negative 6x plus 7. And in this case, all I have to do is combine my like terms. So a 2x and a negative 6x gets me a negative 4x. And a negative 3 plus 7 is 4. Remember, it's proper to put your variables first and in order from greatest to least power, and then the constant. So this is as simple as we can get, and it's in the right order, right? All right, let's try the subtraction then. So that means to take, 2x minus 3, and we're going to subtract negative 6x plus 7. So we need to change our subtraction to addition and change all of the signs in the second function. Remember, that's how we add and subtract expressions together. If we were subtracting, you always change the subtraction to addition, change the signs in the second. So we really have 2x minus 3 plus 6x minus 7. So we'll get 8x minus 10. Right, multiplying and dividing. For multiplying, you're usually going to have to use the FOIL or the box methods. Remember, FOIL is just making sure you distribute everything to everything, and the box method is making the boxes to make sure you multiply everything to everything. So they do the same thing. You're usually going to see it as f of x times g of x, or whatever functions we have. They could do kind of like when they did a composition, do a f times g in here times x. Remember, a small dot means multiplication, a big open dot means composition. All right, so let's actually do the example of f of x times g of x. So we're going to take 2x minus 3 and multiply it by negative 6x plus 7. I'm a FOILer, so again, that's just using the distributive property to make sure everything's distributed. So 2x times negative 6x is negative 12x squared. 7 times 2x is 14x. Negative 3 times negative 6x is 18, a positive 18x. And negative 3 times 7 is a negative 21. So if we combine our like terms, we get negative 12x squared plus 32x minus 21. Right. So that's multiplying using the box or FOIL method. All right, and our last one is dividing. So when we divide, you're going to have a division bar. Again, they can put the division bar between the two functions, and then afterward, you're going to see f of x divided by g of x. And we're also going to make sure that we tell, if we have to, in our domain what number x can't be, because remember, we can't divide by 0. So if we ever have a variable on the bottom, we have to tell what x cannot be, or what number in the domain does not work. So let's actually do this example of f of x divided by g of x when we have f of x equals 2x minus 3 and g of x equals negative 6x plus 7. So we have 2x minus 3 on top, negative 6x plus 7. So to see if we can simplify, is there anything we can pull out of the top? Well, 2 and 3 don't have any common denominator or common multiples, so nope. Negative 6 and 7 don't have any common factors, so we can't pull anything out. So nothing can cancel out here. So this is as simple as our function gets, but before we're done, we have to see what would happen if our bottom was 0, and we want to make sure that doesn't happen. So we want to tell what x can equal. So I'll get negative 6x can't equal negative 7. Divide my negative 6 over, and we'll get x can't equal 7/6. So if I plug 7/6 into the bottom here, my numerator would, or my denominator would be 0, which means we'd be trying to divide by 0, which we know is impossible. So this is our correct function, and this is our correct telling of the domain. All right, so whenever we're dividing, we have to tell what number from the domain doesn't work if we have a variable on the bottom. All right, so I'm just going to go through each of the functions one more time with two new functions. So f of x equals 2x plus 4, and g of x equals negative 8x minus 15. And we are just going to go through each of these following functions and see if we can figure them out. So we're going to start with f of x plus g of x. So our f of x now is 2x plus 4, and our g of x is, that plus looks a weird. All right, so plus, and our g of x is negative 8x minus 15. So if we combine our like terms, we have 2x minus 8x, which is negative 6x, and 4 plus a negative 15 gets us minus 11. Negative 6x minus 11 is as simple as we can get for this expression, so that is our answer. All right, let's do another example of subtracting. So this time, let's take g of x minus f of x. So it's my g of x first, so I have negative 8x minus 15. And from that, we're going to subtract 2x plus 4. So remember, when we subtract, we're going to take our subtraction and turn it to addition and change all the signs in the second expression. So we now have negative 8x minus 15 plus a negative 2x minus 4. So we essentially have negative 8x minus 15 minus 2x minus 4. So negative 8x minus 2x is negative 10x. Negative 15 minus 4 is negative 19. That is as simple as we can get. All right, one more example of multiplying. So we're going to take f of x times g of x. So we are going to take our 2x plus 4 and multiply it by negative 8x minus 15. Now again, you can use the box or FOIL method. Remember, FOIL is just a fancy distributive property, making sure you multiply everything by everything. So I'm a FOILer, so let's do that. 2x times negative 8x is negative 16x squared. And 2x times negative 15 is negative 30x. 4 times negative 8x is negative 32x. And a positive 4 times a negative 15 is negative 60. So we're going to get negative 16x squared. Negative 30 minus 32 is a negative 62x minus 60. All right, so that's as simple as we can get. We have no more like terms, and our terms go in order from 2 power of 1 to no x. All right. All right, one more example, and that's another example of dividing. And so how you're going to probably see it on your homework then is g of x over f of x. And if we do that here, we'll have negative 8x minus 15. Ooh, that 8 guy's super funky. All right, 8. There we go. Over 2x plus 4. We can't take anything out of negative 8 or negative 15. No number goes into both of them. We could take a 2 out of the bottom since 2 goes into both 2x and 4, but it wouldn't cancel out with anything on top. So that is as simple of a number as we can get, this expression. So this is our answer. And then remember, when we are dividing, we have to tell which number can't go on bottom if we have a variable on the bottom, and here we do. So 2x plus 4, if 2x plus 4 equals 0, we'd be in trouble. So we want to find out what x can't equal. So I'll subtract my 4 over, and we'll get 2x can't equal negative 4. And then if I divide by 2, we'll get x can't equal negative 2. So x can't equal negative 2 is part of our answer, because if x did equal negative 2, we'd have a 0 on the bottom. We'd be trying to divide by 0. And remember, that is undefined. All right, so your homework, there will be an operations with functions worksheet. If you weren't in class today, remember that is linked in Brightspace with the where you would turn in this assignment. It'll be called Operations with Functions Worksheet. Click in there, and then it'll be right below where you turn it in. Also, remember, check Brightspace for the activity feed to tell you what your virtual assignments are on your virtual days. And have a great day, Cardinals, and make it count.